Hello everyone, good afternoon. Dear authors and invited guests, welcome to technical session 8F. Myself, Tanish Virmani, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and JR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 25, Jaipur, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held through Zoom on 16th and 17th December 2025. I hope you will all enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question answer. After 9 minutes, I will raise a gentle reminder about the same. There is another request to all participants that you please stay connected us till the closing remarks. If you have any query or update, you can write to me in the chat box. Just before we start the session, I would like to introduce you with the chairperson. The chairperson for today is Dr. Swarna Patil, who is an associate professor at Dr. D.Y. Patil Institute of Engineering, Management and Research, Akurdi. She brings 18 years of teaching experience and specializes in networking and Internet of Things. She is committed to academic excellence, impactful research, and fostering innovation in emerging communication technologies. Ma'am, would you like to say something?
Hello.
Yes, ma'am, you're audible.
Okay. Good afternoon, all. Good afternoon, all academicians and participants. On behalf of Global Knowledge Research Foundation, GR Scholarship LLP, and the organizing team of ICTCS 2025, it is my privilege to extend a warm welcome to you all to the technical session at 8F of the 10th International Conference on Information and Communication Technology for Competitive Strategies. This 10th edition of ICTS marks actually important milestone celebrating a decade of excellence in fostering the global research collaborations and knowledge exchange in the field of information and communication technology. So, this ICTCS 2025 provides a valuable platform for bringing together researchers, academicians, also students to deliberate the state of art and emerging ICT technologies, their applications, strategic implementation across engineering and managerial domains. I commend the organizing committee for successfully conducting this prestigious conference. And so Dr. Suvarna Patil, working as associate professor and head of Department of Artificial Intelligence and Data Science in D.Y. Patil Institute of Engineering, Management and Research. And I am honored to serve the session chair for this technical session. So, sincerely thank you, the conference chair, Dr. Amit Joshi, and the ICTCS 2025 team for this opportunity. This session comprises actually 10 papers presentation. So as sir has already informed you that the presentation will be of 10 minutes and then 2 minutes question answer session. So I kindly request you all presenters to adhere to this allotted time. So and I encourage the presenter to clearly highlight the novelty methodologies and results. And so with these remarks, I let us commence the technical session, and I wish all the best to all the presenters for this session. So thank you.
Thank you so much, ma'am. We would be starting with the first presentation with author Solih Hona for the paper title A Predictive Deep Learning Model for Educational Success Rate. Sir, do we have you?
Yes, good morning.
Good morning. You can start
I'm
your
here.
screen share.
Okay, thanks.
Yeah.
Can I start?
Yes, please.
Okay, thank you. Good morning, everyone, and thank you for joining me today. My name is Swaliuna Kabore, and I will presenting our work, a predictive deep learning model for educational success rate. In this presentation, our work is summarized as follows. We have an introduction. The second is we will take part about a related work. After we will see, then we will see and introduce the methodology and related works. After the experimental result, we will have a conclusion. So let's move to the introduction. To beginning, let's talk about educational data mining. Educational data mining is the research area that applies data mining and machine learning technique to educational data in order to better understand learning process and to support and make decisions for teachers, school, and policymakers. The context of educational success in developing countries. So, many educational systems, particularly in developing countries, struggle with incomplete data, varying temporal coverage across administrative units, and external factors that significantly impact educational outcome. Now that we have introduced the context of educational success in developing countries, let's talk about the motivation for proposing a predictive model for educational success rate. The lack of availability, heterogeneous data of different administrative units challenge or the data of description, such as the conflict zone, war, motivate this work. And also, the limitation of traditional statistical approach motivate. Traditional machine learning approach often fail to perform well in such scenarios, as they typically require uniform data availability and cannot adapt to the varying temporal depths of different regions. So let's move to the related work. Educational data mining have developed along several lines of research. Early, educational prediction focus on student-level outcome using demographic and performance data. The recent work has shifted forward system-wide educational planning using aggregated statistical and traditional time series method. The limitation, current education ensemble approach assume uniform data structures across prediction units, fail to address adaptive temporal modeling based on availability. Our work address this gap through dynamical adjustment to availability data depth per administrative unit, incorporation of diverse context factor through flexible feature engineering, and combination of LSTM temporal modeling with gradient boosting feature-rich capacities. So let's move to the methodology. For our work, we compile a primary educational data from Burkina Faso covering 436 communes from 2009 to 2021, demonstrating how to integrate educational metric with contextual indicators. We implement an adaptive LSTM model that dynamically adjusts its temporal windows based on data availability of each administrative unit. We introduce a novel ensemble learning model by combining deep learning with gradient boosting that incorporates spatial, temporal, and contextual features. The proposed model are structured on it. In blue, we have an LSTM model which captures temporal dependency with variable lookback. In red, we have light GBM model which captures spatial temporal contextual features. And then in green, we have a dynamical weights optimization which combine prediction based on data characteristic. In this section, we are presenting the algorithm tree, which is algorithm used to train our ensemble model. The algorithm is presenting as follows. First, we start by training our LSTM and light GBM model using algorithm 1 and 2. Then we optimize the weight beta via validation. And the next step is consist for loop. Then we select an LSTM model and optimize its weight. In the same loop, we are selected the light GBM model and also optimize its weight. At the end, we combine predictions and uncertainty. Then we give the final prediction with confidence interval. Now, let's move to the resultant starting by data details. Our data is organized on 4 categories, such as identifiers category for data coming and year, performance category for student presented and student admitted, infrastructure category, such as the number of schools, the number of classes, the number of students, and the number of teachers. And finally, geographic information such as latitude and longitude data. So we make some the distribution of availability across communes. This distribution show that most communes having 10 and 13 years of data, with secure zone having more consistent and generally higher years availability than insecure zone. For example, means year of insecure zone is 3, and the means year of secure zone is 9. Also, we make a comparative model performance on Burkina Faso educational data. For this, in the research, we make some treatment of our model, such as we use linear regression model, random forest model, XGBoost model, and our work which is adaptive LSTM, adaptive light GBM, and adaptive ensemble learning. The result table show that the adaptive ensemble achieve the best performance with lower MSC and MI, and the highest R square 0.63 compared to all baseline models. We make also the average of prediction performance by years horizon and predict success rate by zone type for 10 years. Also, we make a height map of predicted success rate by commune and years from the commune as Majuari, Seba, and Diapaga. We can say that the Diapaga consistently higher than Seba and Majuari, which is insecurity zone. Let's move to the conclusion. We present an adaptive ensemble learning approach for predicting educational success rate that address heterogeneous use data availability in real-world educational system. Through our Burkina Faso case study, encompassing 436 communes with 3 and 11 years of data, including security affected region, we demonstrated the efficiency of the proposed model. And future work, we plan to include incorporating exogenous variable extending to multi-level educational systems such as secondary and tertiary, and developing active learning strategy. Also, we're deploying an intelligent monitoring system based on the proposed model to identify at early age a commune with lower success rate. Thank you for your attention.
Hello, am I audible? I think.
Yes.
Yes, yes, ma'am.
Yes, sir. Actually, go to that result slide. Result slide.
Wait, result slide. Okay. Yeah.
Yes, yes. The next one.
Yes.
So in this, as you said, you have compared the linear regression, means the models So
Yes,
yours are the three usage. Yeah, I am able to understand that adaptive, LSTM, this light GS, GBM, and unassemble. So why, Miss?
yes.
So why? What is the novelty in that, Miss? From existing, actually, existing LSTM
Uh,
is there. So why you have given the selected that, and what is the novelty in that?
okay. It's the problem of quality of our data in Burkina Faso. As we presented our motivation, we see that we have a lack of data availability to train our model.
Okay.
On our research, we see that linear regression and random forest
Hmm.
with XGBoost is most used in educational
So,
predict.
on which are the input parameters that you have considered for this?
Yes, yes. We use LSTM, light GBM, and ensemble
Any,
learning.
so that's model you have used. So while giving the inputs to that model, so which are the different features or parameters that you have considered for that model? So on which
We for,
features
for
you
that.
have?
Yes,
Hmm. So, in data processing, pre-processing, uh,
we
which techniques you have used, and also have you considered the feature extraction also?
we it's the data which we use is this
Okay.
information
Okay. Yes. So,
coming. Yes,
what is the overall? In one line, just explain me the novelty of your
you can
project, of your research.
can you repeat, please?
In one line, just explain the outer. Miss, you have mentioned that you have developed the three new models, adaptive, as you said. So, in addition,
Yes.
miss, that they are the three new models that you have developed, or you have researched for that three models. So, can you just in one line explain the what is the novelty of that?
Okay. The novel is our model.
Overall, not for all the say different one. Mm.
You say
What is the main aim of your the of your research?
we, as I say, the main of which we propose the adaptive ensemble model
Okay.
learning is
So,
the
in which
fact that
applications that will be used, and then
yes, it's
which
we
are the
use it.
different applications of the.
But yes, different application. We train our data in
Hmm.
these models such as linear regression, random forest, and XGBoost, adding our adaptive LSTM model, adaptive light GBM, and ensemble model. Our adaptive ensemble model is a combination of LSTM and light GBM, which is presented in our methodology here. We make an
Okay. Thank
LSTM.
you. Okay. Thank you, sir.
Yes.
Okay.
Okay.
I have done from my side. So,
Okay.
um,
Thanks.
yes, coordinators, you can just.
Yes, ma'am.
Mhm.
The next author, sir, you can stop sharing.
Okay. Thanks.
The next author I would like to call is Alima Arif for the paper title Design and Implementation of a Predictive Analytics Framework for Diabetes Detection Using Machine Learning.
Hello, good afternoon, everyone. I'm audible.
Yes, you're audible.
Okay, I'm sharing my screen now.
Yeah.
Uh, I hope it is visible now.
Yes, it is visible. You may start.
All right. What's happening? I have applied the slideshow. The slideshow is visible now.
Yes, yes, it is visible.
Okay. So, good afternoon, everyone. I'm Alima Arif from Indira Gandhi Digital University for Women, New Delhi, India. And today I will be presenting our work titled Design and Implementation of a Predictive Analytics Framework for Diabetes Detection using Machine Learning. So, we all know that diabetes is a chronic disease where delayed diagnosis can lead to severe complications such as cardiovascular disease, kidney failure, etc. From a machine learning perspective, the key challenge is that traditional models often optimize overall accuracy, which can still hide a high number of false negatives. So, in medical diagnosis, a false negative is a far more dangerous than a false positive. So, this directly motivates our evaluation strategy. Uh, Shifting to slide number 3, which is aim and objectives. So the primary focus of our research is to design a predictive analytics framework for early diabetes detection that minimizes misdiagnosis. So specifically, our objectives are threefold. First, to construct a complete end-to-end machine learning pipeline, starting from data exploration to evaluation. And then secondly, the model development to develop and compare multiple ML classification models for diabetes predictions and to explicitly address class imbalance using SMART since diabetic cases are underrepresented. And the third is to prioritize recall during model evaluation, ensuring that true diabetic cases are correctly identified as much as possible. So this is my dataset overview. We have used the PIMA Indians diabetes dataset, which contains clinical and physiological attributes. And the dataset is binary labeled, indicating diabetic and non-diabetic outcomes. And it has total number of 8 features plus one is the target outcome. And sorry. This is the proposed framework or the methodology of my pipeline. So, which follows a systematic machine learning pipeline. So, firstly is data collection. The data set is used in this study is structured clinical data set containing patient level attributes. The data represents a binary classification problem where the goal is to predict whether a patient is diabetic or non-diabetic. The next is data pre-processing. Uh, the zero or the missing values were treated as missing data and handled using statistical imputation techniques such as mean replacement to avoid bias. After handling missing values, feature scaling was applied using standardization to ensure that all features contribute equally during model training, especially for distance-based and gradient-based algorithms. Thirdly, the feature selection was performed to identify the most influential variables contributing to diabetes prediction. This was done using model based importance scores derived from tree based algorithms. Um, and the fourth one is model training. So multiple machine learning classifiers were trained using the processed data set. The data set was split using k-fold cross-validation to ensure robustness and reduce variance in performance estimation. And finally, the evaluation model performance was evaluated using accuracy, precision, recall, FN score, area under curve, and confusion matrix analysis. So these were the machine learning models which we have implemented. These are logistic regression, support vector machine, random forest, and k nearest neighbors. These were the four traditional models which were implied first, but they gave us a model accuracy and lower recall value. So we used optimized XGBoost model to enhance the value of evaluation. So during the process of data exploration and pre-processing, we to get to know more about our data set, we performed exploratory data analysis. So there were certain graphs which we evaluated. So first one is the count plot showing dataset had a great percentage of non-diabetic cases than diabetic ones created to evaluate the class distribution. The next is a histogram in which it is drawn for all numerical features to examine their distributions. Features such as glucose and blood pressure showed near normal distribution, whereas insulin and skin thickness displayed significant right skewness with visible outliers. The third one is correlation heat map. Uh, Correlation heat map showed significant positive correlations, especially between BMI and outcome, which is score is equal to 0.31, and then pregnancy and age, in which the relationship score is equal to 0.54, and glucose and outcome, in which is 0.49. The lastly, we have implemented a pair plot, which was created to visualize the relationships between the features. The next is the confusion matrix of traditional models. We initially evaluated multiple baseline models using stratified cross-validation. While these models achieved moderate accuracy, their recall values were limited, indicating that a significant number of diabetes was still missed. We can see here in the logistic regression that we got the accuracy of 76.9, that is approximately 77%. Then SVM accuracy is 76.5%, and KNN has the lowest accuracy, that is 72%. And again, Random Forest has similar accuracy to the SVM, that is 76.5%. Uh, so this is giving us a moderate value, which confirms that accuracy and also we can see that recall values are also very low. So this confirms that the accuracy is insufficient and it reinforces the need for class balancing and more advanced and simple method. So to enhance our metrics, we used optimal XGBoost model, which gave us pretty good values for evaluation. To address class imbalance, we applied SMART, which generates synthetic samples of minority diabetic class. After balancing the data, we trained an XGBoost classifier and optimized its hyperparameters using grid search with stratified cross validation. I'm sorry.
You may continue. You may continue.
Okay. Okay, so this here we can see I have also updated the screenshot of the accuracy score and the AOC curve also. So this combination we can see that out of 100 actual diabetic cases, the model correctly identifies 86 patients, resulting in a recall of 86%. This means only 14% of diabetic cases are missed, which is a critical improvement for medical screening. And the overall accuracy is approximately 82%, and the AOC of 0.825 confirms good discriminative ability across decision thresholds. So after that, we have also done some visualization insights and seen some trends in all over our data. So first one is histogram of age for diabetic and non-diabetic individuals, which revealed that the likelihood of diabetes increased with age, as younger individuals were predominantly non-diabetic. The next one is a scatter plot between glucose and insulin, which indicated that individuals with both high glucose and insulin levels were more likely to be diabetic. And the third one is age versus BMI scatter plot, which showed that older individuals with higher BMI were more prone to diabetes. And the next is box plot of pregnancies, illustrated that females with a higher number of pregnancies had great diabetes risk. And lastly is the box plot for diabetes pedigree function, demonstrated that when this value exceeded by zero point 0.5, the probability of diabetes increased significantly, highlighting the genetic and hereditary aspect of the disease. And lastly, in conclusion, in the future work, I would say that to conclude this study, I would say that uh, we present a recall-focused machine learning framework for diabetes detection. So by combining careful pre-processing, smart-based class balancing, and an optimized XGBoost model, we have achieved improved sensitivity without sacrificing the stability. And also, the result demonstrate that the machine learning systems designed with clinical priorities can be both accurate and ethical and sound. In the future work, we can focus on a larger or a more diverse data set and on explainability method like faithfulness using SHAP for deeper interpretability about the features majorly contributing to give a prediction of final outcome. So that's all from my side. Thank you for your attention.
Hello.
Yes, ma'am.
Yes, ma'am. So, as your research is on diabetic, so go to your second slide.
Yes.
Okay. So, in this, as you said, okay, you are going to implement for this diabetes. So, time consuming diagnosis, just which models you have used and explain means objective means how you have identified the research gap, because nowadays many research has been done in this area. So
Yes.
yours research should be different from the existing whatever
Okay.
the models are being developed.
Mm-hmm.
So how you have identified the research gap and how many papers you have referred to
I
identify
have
that research
referred
gap?
multiple papers
Multiple,
around
multiple means count.
around 20 to 25, if I remember the count. I have considered them. They have and multiple of the papers they have used the same data set. Also, they have used the clinical based data set or directly introduced directly and introduced or a review data set, or they so it depends on the variety of the data set also, and also traditional methods you were talking about. I have used logistic regression, SVM, and KNN. So they gave me a good accuracy, but that was a moderate accuracy. I cannot rely my model on that only, so I have to improve it. So further, I used the XGBoost model to
Nowadays,
improve.
the same models are being used. So you should have added some any fusion model. This is my suggestion. So you
Okay.
should have used any fusion model and latest Gen AI model also, so that it would have helped. And explainability also you should have added. So these are the
Yes, in the
suggestions.
future scope, I have added this thing to
This in
add on.
future scope, but before, because as many models are being developed.
Okay.
Okay. Have you
Yes, ma'am.
used hyperparameter tuning?
Yes, I have applied that too.
Mm. Yes, thank you.
Okay, thank you, ma'am. May I stop sharing my screen now?
Yes, please.
Okay, thank you. Thank you, team.
I would like to call the next author, Hetvi Bhora, for the paper titled Dynamic Price Optimization for E-commerce using Demand Prediction and Competitor-Based Adjustment.
Hello.
Yes,
Yes, can I share my screen?
yes, please start.
Is my screen visible?
Yes, it's visible.
Okay. So good afternoon, everyone. I would like to start my presentation on the topic Dynamic Price Optimization for E-commerce using Demand Prediction and Competitor-Based Adjustment, whose co-authors are Hetvi Bora, Shruti Nath, Riya Agrawal, and Swati Vaishnav. So introducing the topic. So in this fast-paced era, e-commerce is a landscape, and traditional static pricing models are no longer sufficient. So our team tried to build a cutting-edge, production-ready dynamic pricing engine that predicts short-term demand using ML, that is machine learning models, and recommend price maximizing profit maximizing price using real world business constraints. So, this innovative solution was leveraged with the help of machine learning models to forecast short term demands with high accuracy, enabling a recommendation of prices that not only maximize the profit, but also adhere to the critical business quadrilles. This presentation will dwell in problems, in topics like problem motivation, research motivatives, uh, system architecture, data sources, feature engineering, demand prediction models, and core price optimization logic that drives our engine. So, similar works that have been done before are adaptive optimization, gradient boosting machines, uh, support vector machines with business intelligence, AI methods, that is artificial intelligence methods, Bayesian techniques, rule-based techniques, and stochastic approaches and reinforcement learning. But the results were not consistent, and there were a lot of assumptions that were made in their implementation. Also, there were some ethical concerns and generalization problem in the implementation of these works. So we are moving forward to how our work is different from the similar type of the work that were done by previous authors. So the problem motivation was e-commerce is categorized as intense competition right now, and its significant seasonality makes the static pricing inefficient. So these are the three main motivations for us to take upon this topic. Static price failures. So if a business is keeping the price static, there are a lot of failures that business venture itself faces. Second one is competitor price wars. So if a company is selling some product and the competition company has its price lower, it will face losses. The third is demand fluctuations. So a product is having different prices according to the seasons, the demands, and the sales. So it should be taken into consideration. There is a critical need for data-driven, explainable, and safe dynamic pricing solutions to be needed for solving these problems. Our primary goal is to maximize the profit and moving beyond prediction accuracy, which is always the aim of other authors. So, research objective. Uh, uh, these are the four research objectives that were our main motivation. First one is end-to-end engine development. This was a complete dynamic price engine that was supposed to be made by us, which consisted of data ingestion, demand forecasting, price optimization, and real-world data sets that would be used to prepare a dashboard. Second one is machine learning based demand prediction to accurately predict the demands, and also to give a accurate price based on profit maximization. Third one was business quadrille integration, in which we focused on plus or minus 5% of price volatility in order to ensure that the market stability and customer trust is our main center of concern. The fourth one is profit centric model comparison, in which we evaluated and compared different models, not just on traditional matrices like RMSE or R square metrics, but critically on their direct profit impact, aligning with our core business objective. The third is high level system architecture, which led us from data to the decision of the whole project. So, firstly, we started with data ingestion, where we collected vast amounts of data from historical sales, competitor prices, and market trends. Second one, we focused on feature engineering, where we transformed the raw data into meaningful features for our prediction. Third one was demand prediction with the help of machine learning models to forecast short-term product demands. Fourth one was constrained price optimization. So our main goal of this project was to implement optimization, where our main goal was to maximize the profit with the corresponding price of the product. And fifth one was dashboard and reporting, where we are presenting the insights and recommending the price which are informed and decision making. So our data sources were from three main places: sales data, which was oldest Brazilian e-commerce data set, which provided SKU data level transaction records of the products that we were working on. The second one was competitor pricing, where we sourced the books to scrape website and cached the HTML data to allow us to monitor the competitor pricing and react swiftly to the market changes. The third one was demand trends, where we use Google Trends to get the data regarding the demands that are for a particular product, and we use Parquet cache for effective accessing so that there is no load on our dashboard. Now feature engineering. So some of the features that were inculcated into our project's data were temporal features like day, week, month, and weekend indicators. Then pricing features, which were calculated base prices of 28-day median and discount percentage to understand the impact of pricing strategy on behavior of customers. Competitors features, these were derived from the competitor mean price, which we fetched from competitors websites. Then inventory signal, which indicated the product availability, potential stockout effects on demands, etc. And external demand, which was cached from the Google Trends score to capture broader consumer interest and macro demand shifts, providing a leading indicator for product popularity. So the models that we used for demand predictions were linear regression, Prophet, XGBoost, and Light GBM. So linear regression is the baseline model for understanding the linear relationships. After that, we moved to Prophet, which was time series based forecasting, in order to see that how our prediction works with seasonality. Then we moved to XGBoost, which is a tree-based machine learning advanced model for looking at the performance of it based on our data set. And then lastly, we tested it on light GBM, that is light gradient boosting, for optimization for speed and efficiency. So why was light GBM considered as the best? Because it works well with tabular data. It was best for RMSC and business translation, and it was simpler model, and it was able to model the complex demand price relations easily. Price optimization logic, which is the main novelty of our project. So first of all, this was a 5-step process in which we generated the candidate pricing, that is price points for generated current pricing. After that, we predicted the demand for each price, that is for suppose there is an XYZ product's price, we will generate candidate pricing for it, and we will predict the demand for each of the predicted price in order to see that whose demand is highest compared to the price. After that, the third step was to compute the profit, which was the main thing. So we predicted the price in such a way that profit was the maximum to be inculcated from the price. Then fourth one was applying the volatility constraints, which is plus or minus 5% of the volatility of the current price, so that our model doesn't perform in a worst way if the market is volatile. The fifth one is selecting the profit maximizing price, which was based on the third steps formula, that is price minus cost into predicted demand. For this, we used grid search CV, that is it was selected because it is explainable grid search method, which is transparent in order for the end users to be explained, and it can be used easily for the real world deployment as well. So the key
Excuse me,
results of
ma'am.
our
Just
project.
to give you just a gentle reminder that 9 minutes of the presentation are up.
Yeah, okay. So the best model was light GBM with RMSE of 0.205% and R square of 0.92, which was a commendable result compared to the other relatable projects. And it also gave a profit improvement of 13%, which was commendable. And this project also gave the elasticity insights. That is, if there were this elasticity was right skewed, which showed that only a small fraction of the products were such that they were price sensitive, and so those were the only ones that are to be taken into consideration for a different model. These are the contribution and the conclusions that I drew from this project. So this was practical ML-based dynamic pricing system. It integrated profit, elasticity, and prediction, and it was product-ready design. Future works includes casual pricing experiments, contextual bandits, multi-objective optimization, and scalable deployment to be done. Thank you.
Ma'am, do you have any questions for the presenter? I think there's some issue in the technical issue. So you can stop presenting. Thank you so much.
Yeah, thank you.
We would start with the next presentation. And the next author is Darshan Gera with the paper title Efficient Fine-Tuning Methods for Facial Emotion Recognition.
Yeah, can you hear me?
Yes, I can hear you. You
Sorry,
can start
sir,
your...
I was not able to because of my internet connection.
Yeah, no problem, ma'am. You had any questions for the previous presenter?
Uh, yes, just.
Yeah, sure. You can continue with that first.
Shall I share my screen?
Yes, sorry.
Yeah,
Yeah.
Darshan sir, could you please wait for a second, sir?
Yeah, I need to unshare or
Yeah,
you can share.
if you could wait for a minute or so.
Yeah, means if I stop.
Yeah, you have
Okay.
to stop. Yeah, Hetri ma'am, you can start your screen.
Yeah.
More restricted to students.
Can you see the screen?
Yes, it's visible.
Okay.
Just, yes.
Yes, ma'am.
As just I want to ask only one question.
Yeah.
So go to your result side slide.
Yes.
Okay, so in this, I think these are not the result properly that you have mentioned. So you have just given the it is means it is just this graph is not proper. I want to say,
No,
and
ma'am, it's just for visualization.
yes, but you should have represented it with the proper graph. And you should my suggestion is that you should do more, you refer more papers. I think you have must have you means every researcher should refer at least 40 to 50 papers. 20 to 25 papers are not sufficient, so this is for all. And you should compare the various models also. So I think you should work more on your research. Okay, thank you.
Okay, ma'am.
Hello, Mr. Darshan Gera. Sir, you can start presenting.
Yeah. Can you hear me and can you see my
Yes,
presentation?
yes, everything's fine. You can start.
Okay. So, good afternoon, everyone. I am Darshan Gera. I will be presenting our work title Efficient Fine Tuning Methods for Facial Expression Recognition. This work was done along with my students and fellow researchers at the Department of Mathematics and Computer Science, Shri Satish Sai Institute of Higher Learning. Just a second. Yeah, so to begin with, I would like to thank the organizers of the conference for giving me an opportunity to present our work. My sincere gratitude to Bhagavan Sri Sathya Sai Baba, who is the divine founder chancellor of Sri Sathya Sai Institute of Higher Learning. And this will be the brief outline of my presentation today. Let me start by motivating the problem. So, facial expression recognition, or FER, is the science of making computer understand a person's internal emotional states. Now, this FER technology has many real-life applications like design of machines and robots, which can understand people behavior and effectively serve as digital assistants. There are other applications in the related fields like driver fatigue monitoring, mental health analysis, e-learning, and so on. Now, the challenge is that the deep neural networks which are used to train these FER models are computationally and storage intensive. The standard approach of fine-tuning the deep neural networks requires updating millions of parameters, which makes the deployment on a edge device very difficult. So, to address this gap, our research goal is to develop a parameter efficient fine tuning method which has high accuracy. At the same time, it has the reduced number of parameters for training so that the deployment on a edge device becomes little more easier. Now, to understand our contribution, we need to know the recent parameter efficient fine tuning methods like the LoRa and Dora. Now, the LoRa stands for the low rank adaptation, and the main idea in the LoRa method is that when we want to train a model for updating its weight, we don't update the whole matrix. Instead of that, we break the matrix, or we write the matrix as a product of two low rank matrices B and A. Now, the beauty is that the rank of B and A is much, much lower than the rank of W. As a result, the number of trainable parameters get reduced, and training becomes much faster, and it reduces the number of parameters and thus the memory requirement. Now, building on the success of LoRa, the Dora method, which is basically the weight decomposed low rank adaptation, it decomposes the weight matrix into two components. One is the magnitude and another one is the direction. Now, Dora method applies the low rank decomposition on the direction component, not on the magnitude. It learns the magnitude in a normal way, whereas the direction component it applies the LoRa method. However, the Dora uses L2 normalization to normalize the directional component, which provides it a greater representation flexibility. Now, the L2 normalization is a standard method of normalizing a vector, but when it comes to the convolutional neural networks, it has a problem. Now, what is the problem? That L2 normalization treats all the dimensions equal. But when we use this method on the convolutional neural networks, the convolutional neural networks have a special property. The property is that they have a low rank structural redundancy. It means that all the dimensions are not all the features are not significant. Now, when we do L2 normalization, we are not exploiting this low rank structure of convolutional neural networks. Instead of that, we use something called the nuclear norm. Now, nuclear norm of a matrix is nothing but the sum of the singular values, and which can be found using the singular value decomposition. So now our proposed hypothesis is that if instead of using the L2 normalization in the Dora, we use nuclear norm or nuclear normalization, it will promote the low rank solution, and which will solve the problem of the uh, structural low rank redundancy in the convolutional neural networks. So this is our proposed method called DORA with nuclear norm. So uh, the if we want to understand the diagram, on the left hand side we take a weight matrix which we want to update or learn. So we decompose it as a magnitude and the direction. Magnitude is m and the direction is basically the v. Now in the normal, when we want to take the find the direction component, we take the L2 norm, but in our proposed method we have taken nuclear norm, and in the nuclear norm is nothing but the sum of the singular values. And finally, when we have learned the low rank adaptation on the on the direction component, we again reconstruct back the given matrix W dash by rescaling based on the our decomposition of using the singular value decomposition. So this is the proposed nuclear name based DORA. Now, to demonstrate the performance of our method, we implemented these methods on the FER dataset, which are the benchmark dataset. One is RAFDB and another one is FER plus. The RAFDB dataset contains 7 basic emotions of happy, sad, angry, neutral, and others, and it has 12,271 training images and 3,068 test images, whereas FER Plus has 28,709 training and 3,589 test images for 8 emotions, including the concept. And for the training, we resize all the images to 224 by 224 and apply standard data augmentation. The baseline architecture which we used was ResNet 18 and 34. And for optimizing, we use Adam W optimizer with one cycle LR scheduler. The standard cross entropy loss was used for training. Now we report the mean accuracy by running the experiment 3 times. And it is to be noted that when we train using the nuclear norm, we need to compute SVD, singular value decomposition, which is already available in the PyTorch or TensorFlow for the backward computation, backward propagation. So we don't have to compute the derivatives for back propagation manually, but when we do the back propagation using SVD for the training time, the training time increases significantly, but during that inference time, it does not affect. Now coming to the performance of our method, for quantitatively comparing, we have compared our proposed nuclear DORA with LoRa and as well as DORA with L2 norm, and we find that on FER plus dataset, the nuclear norm DORA performs competitively equal to the LoRa and DORA L2 norm, whereas on the RAFDB method, our proposed method gains a performance by a margin of almost 5%. And it is to be noted that the RAFDB is more challenging dataset than the FER plus, having more occluded and pose variations. Now coming to the performance gain in terms of the parameter efficiency, we find that when we look at the lower leftmost rank 8 model, it uses only the 561K number of parameters, which is just the 5% of the total parameters. But there is a significant reduction in the amount of memory required by 95%. When we look at the rank 64, the rank 64 model uses around 4.47 million parameters, that is almost 40%, but it has a comparable performance to the almost like a to the full model, just a slight degradation in the performance. Whereas the full model requires huge number of parameters, and it requires 33% longer training time, which is a limitation, but that limitation is only during the training time, not during the inference time. So by using rank 8, we reduce the number of parameters and don't drop the performance as significantly as could be. We also performed ablation study comparing the LoRa, DORA L2, DORA with L2 and as well as with the nuclear norm on the different batch size of 32 and 64 and as well as rank of 8, 16, 32 and 64. And we find that the DORA method with nuclear norm, which is in the yellow color, is performing consistently better than all the other methods or across the different ranks and different batch size on the RAFDB dataset. Next, we also
Excuse me,
did,
sir. Just
yes,
like this is just a gentle reminder that the presentation time is up, sir.
okay, I'm just concluding. Next
Yes,
is
sir.
we did the qualitative analysis using the GradCam results and compared the attention maps using our method and DORA, when we found that the DORA with nuclear norm performs is able to focus on the more salient regions. And finally, to conclude, in this work, we have proposed a nuclear norm-based DORA method by replacing L2 normalization in the DORA method, which is effective in the convolutional neural networks. And we have shown superior performance and using both the quantitative and qualitative way. One of the future work would be to reduce the training time by finding the approximate methods for the single value decomposition. And another extension can be to use this method for the transformer based methods, architectures, and large language models. These are a few of the important references used in our work, and our source codes are available publicly on the GitHub repository. Thank you, and I'll be happy to take any questions.
Yes. Let's go to your conclusion slide, please.
Yeah. Can you see, madam?
No, still not visible.
I think I have to share one second. Now is it visible?
Yes.
Yeah.
Okay. So, as you are saying that you have accuracy, means it is enhanced by 5.06.
5%. Yeah. On
Okay.
one
So,
of the data set, it has improved by 5%. Another one, it is not significant improvement. It is just
okay. So,
marginal.
okay. So how many records or how many
Images.
records?
On RAFDB, yeah, madam. On RAFDB, we had around 12,000 training images and 3,000 something test images. And similarly, on the other data set, also we had. So this 5% improvement is on the around 3,000 images.
So, means it was not for a higher, means it was not actually giving the proper performance for the, if there are more number of records. 12,000, it was not giving proper
No,
accuracy.
madam.
Mm.
It is giving on one of the data set, not on the another data
Okay,
set.
okay, okay,
Yes,
okay.
madam. Yeah.
As you have mentioned here, the qualitative analysis demonstrate the more localized.
Yes.
So, can you elaborate that one?
Basically, what I mean to say is, one second, I'll show you. So basically, what we are saying is, if we look at the this salient regions, the GradCam plots are this red, yellow, greenish uh, feature maps, so, or basically the GradCam plots. So these regions, we are saying they are more pronounced towards the salient regions in the face. Like in this case, if you look at the happiness on the top and the bottom, in the top one, it is only one-sided, and the down one, it is more the eyes, both eyes are covered. Similarly, if we look at the rightmost sadness, it is focusing only on the one side just below the eye and then right side of the nose. Whereas in the downmost, it is focusing on both the eyes and the nostrils. So uh, the region below the eyes is capturing the more attentively it is being captured.
Okay, okay.
Yeah.
Okay, okay. Thank you.
Thank you.
Yeah. I would like the next author, Santosh Kumar S., for the paper title Enhancing Data Representation Through Deep Learning Based Automated Feature Engineering.
Yes, sir.
Yes, sir. You can start your screen.
Yes, sir. Sharing the screen. Is my screen is visible?
Yes, sir, it is visible.
Yeah, thank you, sir. Good afternoon, everyone. I am Santosh Kumar. Today I am going to present our research work on enhancing data through learning based automated feature engineering. The core idea of models. Hello,
This you can continue.
is screen visible, ma'am?
Yes, it's visible now. You can start.
Yeah, thank you. Here in abstract, feature engineering plays very crucial role in machine learning performance. That is, traditionally, this process is manual and highly dependent on domain expertise, which makes it time consuming and difficult to scale. So in this work, we propose an automated feature engineering approach using deep learning. In this deep learning, we use CNN, that is convolutional neural networks, to learn meaningful patterns and autoencoders to create compact and refined feature responsibilities. And experimental results shows improved accuracy, better generalizations, and significantly reduced pre-processing efforts. Here in introduction, yeah. The performance of any machine learning model is strongly dependent on the quality of input features. However, traditional feature engineering has major limitations, such as it is manual, and traditional feature engineering models it is slow and it does not scale well for large or complex data sets. So deep learning offers a solution by automatically learning useful data representations directly from the raw inputs. This our paper focuses on enhancing data representation using deep learning based automated feature engineering techniques. Now we can see, let's clearly define the problem here. Manual feature engineering, as previously said, it requires significant domain knowledge, involves extensive human efforts, and often fails to capture complex and non-linear patterns. Additionally, traditional features does not generalize well across different domains and datasets. So there is a clear need for automated, scalable, and domain-independent feature engineering approach. For this problem, we proposed our work, that is automated feature engineering framework using deep learning. In this, components of proposed work are like use of CNNs to extract meaningful patterns from raw data and applying autoencoders to compress and refine the learning features and also improve minds shell data sets. In methodology, I'll briefly explain the workflow here. First, data is pre-processed using normalization, encoding of categorical values, and handling missing values. Next, CNN layers adapted for structured data are used to extract features. These features are often then passed through autoencoders, which remove redundancy and retain the most informative representations. Finally, the optimized features are used for classification and performance evaluation. Here, the combination of CNN and autoencoders allows the model to learn complex relationships automatically, and also it reduces the noise in the data, and it can generate compact and meaningful feature representations. This eliminates the need for manual feature selections or handcrafted transformations. Here we can see a deep learning pipeline for feature engineering. This figure shows the complete deep learning pipeline. Raw data flows through the pre-processing, CNN-based feature extraction, and autoencoders-based compression before the final model evaluation. This pipeline is fully automated and scalable across different data sets. Coming to the results and discussion, here the proposed model achieved higher accuracy compared to the traditional learning methods. The combined CNN plus autoencoders approach performed better than CNN only models. That means models which have only CNN, our model performed more than that, and also shallow learning models. Results were consistent across healthcare, finance, and other tabular data sets. Here we can see in the performance evaluation, automated feature learning helped, which can reduce noise in the data, improve generalization, and maintain stable performance across domains. This confirms the effectiveness of deep learning based feature engineering. This slide also summarizes the model performance across benchmark datasets. You can observe the consistent improvements here in that means of accuracy, robustness when automated featuring engineering is applied. So this highlights the advantage of learned representations over handcrafted features. Concluding the work here, deep learning based automated feature engineering significantly improves the data representation. The framework removes dependency on manual and domain specific feature designs. And also, the model is robust, scalable, and effective across the multiple domains. In future, we are planning to extend the approach to unstructured data such as images and texts and exploring the real-time and streaming data scenarios. These are the few references I put it in from my research paper. Actually, we have more references in our existing research paper. Thank you.
Hello. Hello.
Yes, ma'am, you're audible.
Yes. Can you go to your objective slide?
Yes, madam.
Objective. So you have not mentioned actually object. This is the actually objective, which
Yeah,
you
ma'am.
mentioned as a proposed work.
Yeah, ma'am. Proposed work means objective, main
So,
objective of
as
our research
yeah,
work, ma'am.
you have used the CNN to so why
Yeah, ma'am.
actually you have used CNN and and why you have selected the CNN? So have you compared it with the other model also?
Yeah, ma'am. Why we took CNN means it is very compact to extract meaningful patterns from other models, ma'am. Compared to CNN, in CNN we have multiple layers, so it is easy to extract patterns. When it comes to pattern extraction, CNN is the best model, ma'am. So we took that.
Okay. So pattern extraction. So in that while extracting the pattern or what? So how many layers you have used?
Yeah, ma'am. It is 27 cross 32, ma'am.
Okay. And have you tried the other one also? How was the performance? So you should have shown that comparative analysis, Miss. So you have worked on how many layers and while extracting that. Uh, so it would help the others to understand properly what your research idea. And in feature engineering, how many, Miss? So total, how many input parameters you have worked and how through feature extraction, how many parameters you have then extracted? Can you explain that? Hello.
Yes, ma'am, you're
Yeah,
audible.
ma'am. Hello.
Yes. Can you explain how many on how many features you have worked? Features means input parameters.
Yeah, ma'am. We considered three benchmark data sets for these parameters, ma'am. One
How
is
many columns are there in that data set? How many records and how many columns?
ma'am, it having four records when it comes to healthcare data sets, and it's around 3,000 columns, ma'am.
I think it is vice versa. 3,000 rows, I think. And the columns are 4, I think.
Yeah, ma'am. Sorry.
Should be like that.
Yeah.
Okay. Okay. Thank you.
Thank you, ma'am.
Over to you, coordinators.
Yes, ma'am. I would like the next author, Masira Kulkarni, for the paper title Exploring AR/VR for Dyslexic Student in Education. Do we have you, ma'am? If the co-authors are also not available, then we can start with the next author. Irene, for the paper title Herding Camels in the Digital Age, the case of Omani camel herders and keepers.
Yes, I am here. Can you
Yes.
hear me?
Yes, I can hear you. You can start your screen.
Is my screen visible?
Yes, it's visible.
Okay, so good afternoon, everyone. I'm Dr. Irene of Mazun College. I'm presenting our paper with my co-authors, Dr. Roel Ancheta, Dr. Jerome Vicencio, and Ms. Casala Yusupi, entitled Herding Camels in the Digital Age, the Case of Omani Camel Herders and Keepers. So, camels are vital in the lives of Omanis in the Sultanate of Oman due to their close connection with the heritage of the past. Camel is noted by its high adaptability to the nature in the Sultanate's drylands and its climate, especially during summertime. As you all know that during summer, we are experiencing very high temperature here in Oman. Sometimes it will reach until 50, and camel is one animal that it can sustain the hotness, especially in the desert. So since long time, the people in Oman are relying on camels and donkeys as a form of their transportation. And this is you know this no during the caravan period and actually until now. But now here in Oman, there are different ways how they are using the camels. So and the price of camels varies on their use. Some people are taking care of the camels because they will use the meat of the camels or the milk of the camels, and others are not only in Oman but in GCC countries. They are taking care of the camels or herding the camels because they are using this for sports, or they have this one camel race which involve a big amount of money, and each camel for racing will cost a very high amount of money also. It's very expensive. So those for racing is more expensive than those camel that they taking care for eating. Okay? So these camels are mobile animals that can move more than 100 kilometers from the home base, and they can walk long distance in the desert. So it is difficult to locate and monitor them quickly without the help of devices or equipment. And just for the information of other people, when you are herding camels, so they will form in a group, and actually psychologically in a group there will be leader. Okay, so camels are walking by the group and the leader will lead them. So the herd will follow the leader. Okay? So in Oman, one of the challenges they encountered in the camel herding is locating their lost camels, since these camels are traveling, especially if, if the leader is like pregnant or conceiving in a longer distance. Apart from difficulty to locate, monitor these camels, the presence of camels on the roads and highways are also serious problem that cause many accidents. And another information that I would like to share to you, in Oman, if you will see camel crossing across the road, you need to stop. Because if you hit one camel, you will be penalized and you need to pay a big amount of money. So this animal is very precious, no? Here in Oman. So one of the solutions that camel owners use by using animal GPS tracker known as the global positioning system device to locate their missing camel. So nowadays, because of the technology, the herders are using this GPS, putting this to the camels so that, for example, they will go in some place, they can locate it. However, despite of using this digital device, they encountered some issues and challenges that affect the sustainability of their herding practices. So, the objective of this research is to investigate the extent of using animal GPS tracking device and the challenges encountered in monitoring and tracking missing camels in the desert using the device. This research would like to answer the following question. What is the live experience of the participants in using GPS tracking device in camel herding? How GPS tracking device benefits camel herders in monitoring and tracking their herds? What are the limitations faced by camel herders in using this device? How these limitations affect the sustainability of camel herding practices? For the research methodology, this investigation used qualitative research method in describing the life experience of the camel owners and shepherds on the extent of using GPS tracking device and in monitoring their herds. So the respondents use a qualitative research method to offer a comprehensive result. And the research design. The respondents use phenomenological research design. So, aside from that, we use the focus group discussion. So, in this research, we went to one desert area, camel farm. So, we interviewed 8 respondents. These are camel herders, no? And we asked them, this is a face-to-face interview, and we asked them about we have the structured questionnaire, and this is the output of our research. So we use thematic method. So here are the different themes. For example, difficulty in managing and monitoring tracking camels, which is also, this number 1 will answer our research question, what is the life experience of the participants in using GPS in camel herding? So, difficulty in managing, it means all the respondents experience difficulty. In what areas? So, challenging tasks, and it's hard to take care of, the entails responsibility. It's not easy to take care of the camels actually, especially if one farm will take care of at least 30 to 100 camels. So, it's not easy. What kinds of digital devices use? So, animal GPS tracker. Just to inform you, so all the 8 respondents use this, no? As you can see, we have here general. General means it is common. Common to all these herders that they will use this GPS. And what are the types of GPS? This is our question 2, no? How GPS tracking device benefits and monitoring the tracking health. So we have the 2 kinds of GPS. We have the collar GPS and the shoulder. So shoulder is not common. This is only variant. But in general, most of them use the collar GPS. In terms of the operation of the GPS, it can be battery powered, which is most common, and solar powered, which is typical. Few of them used. So it used signal from the satellite, of course, connected to the smartphone or tablet. What will happen actually? They will put the GPS device to the neck of the camel or to the shoulder, and then it will be connected to the phone of the herder. So they can monitor where is the location of the camel. And activated through GPS app. Of course, there must be app for the device, and internet connection is not needed. What are the key features of tracking device? It can monitor the live location and movement of the camels, monitors health condition, provide access to available water resource, analyze the historical data. It provides alert notification if camels cross the roads and beyond borders. So these are visible in all the applications that are connected to the devices. In
Excuse
terms of
me.
the
Excuse me.
challenges
This is just a gentle reminder that
encountered.
9 minutes are of the presentation are up.
Okay, just I will sum it up. So, challenges, what are the vulnerability, accuracy, and device, camel crossing, and animal vehicle? So, just to end and just to show you, so these are the sample of the GPS tracker. This is for the neck. And these are the features of the application. Okay? So, you can locate the location, the health. Now, the findings. The finding shows that GPS tracker is an effective tool to track the camels. And through the device, it is considered effective tool. These are the benefits and limitations. It has been noted that the use of GPS tracker for camel herding offer advantages and disadvantages. One notable benefits of using the device is generally perceived by the hello?
Yes, you're audible.
You can see my screen.
Yes, yes.
It revealed that GPS tracking device has key features that are beneficial in camel management, particularly in monitoring and tracking camels' whereabouts. The tracker can provide access to available water resources, which lead to camel to point out where to find water for them hydrated. This finding similar to Dick et al., who concluded that using GPS could provide accurate water resource, which could potentially benefit the camel herder to identify available water resources in the certain area. Do you have any question? Because I'm running out of time, as what you said.
Hello.
Yeah.
Yes, so go to your objectives mail. Have you prepared it? Objective? Have you drawn any result? Have you drawn any result from your research? Can you explain that research? Means
Huh?
any outcome of your research? Means how you have measured or how you have evaluated the performance of your model?
Actually, this is a qualitative research, as I mentioned.
Okay, this is
Okay.
review. Okay.
Yeah. And what is the objective? To study, to
Ah,
investigate the extent of using animal GPS tracking device and the challenges encountered in monitoring and tracking missing camels in the desert. To
but
review,
but
actually, this is at our initial phase because
yes,
we are
in
in the
qualitative research, you must have compared the existing methods then.
Yeah, we are comparing actually.
Hmm.
We are actually this is
So how?
existing method.
So which method was having the best performance?
We don't like to know. This is not the aim of our research. The aim of our research is cleared in our research question. It's we are not about the performance. We want to know the use of this benefits for the herders, what are the limitation first, and what is the recommendation. Because this is a first phase in our research. We want to know about all this GPS tracking device because we want to develop to improve these tracking devices.
Okay, okay, thank you.
Any question? Okay. Thank
Yes,
you so
thank you.
much.
Sir,
I
over to
think
Thank
you,
no
you.
more
sir.
question.
Yeah.
Huh?
Tehsin sir,
Hello, am I audible?
Yeah.
yeah, hello.
Yes,
Yes, ma'am,
yes.
you can stop sharing. Yeah, you can be on mute. Yeah.
I
Wait,
apologize for the
one second.
delay. I had a technical error.
Yeah, this is the paper, right? Masira Kulkarni?
Yes, actually she is hospitalized,
Yeah,
so we
sure.
are the co-pilot. Yes,
You
thank
can
you.
start.
Okay, someone else is sharing, so I couldn't share. Can you see my screen?
Yes, I can see that.
Yeah, thank you so much. Hello everyone. I am Tehseen Sheikh, co-author of this Exploring AR VR for Dyslexic Student in Education. So let me start with what is dyslexia. Dyslexia is a specific learning difficulty that primarily affects reading, spelling, and writing. Even though the learners often has average or above average intelligence, dyslexic students may struggle with decoding words, processing written text, and maintaining confidence in traditional classroom settings, which can lead to frustration and disengagement. And as the title suggests, AR and VR, emerging technologies like augmented reality and virtual reality. Just let me just move to the next slide. Hello,
Yes, the screen is visible.
the screen is visible. Can you see my screen now?
No.
Yeah, can you see it?
Yes, the email is visible actually. If you need some time, then we can continue with the rest of the presentation and then you can come at the last.
I have shared the screen. Yeah.
Yeah, it's visible. You may start.
Yeah. So the dyslexia is a specific learning difficulty, like I said. So the children facing difficulties in their early education is our main focus. So the letter writing, recognition of the letter is what we found difficult in them, and the traditional classroom methods and the the whole classroom environment is not suitable for their academic growth. So we thought about this problem, this issues, and we have come up with this augmented reality and virtual reality, and with the help of this technology, transforming our ideas into design learning experiences. So these immersive multi-sensory environments have the potential to support dyslexic learners by presenting information visually, interactively, and in more personalized way. So the child, whoever is studying through AR and VR, he or she gets in-hand experience, whether they if we say about the attention deficient child, so the child will get more interactive with the system, and the teacher who will monitor the child's growth will also notice that the child is getting very much help. The objective of our whole project was to evaluate AR and VR's effectiveness in addressing dyslexia specific challenges like word decoding and text processing through interactive 3D simulations and gamified content. Whatever we do, we have kept in mind that we are making the whole project for a child. So the child should see it as something that is very cool or very gamified stuff. And our next objective was to provide evidence based recommendations for educators and developers to integrate the technologies into classrooms, reducing frustration and boosting confidence of the child by 25 to 40%. So these are some motivated points that I had just spoken about, that enhancing learning accessibility of the child, bridging the technology gaps, because AR and VR is, you can say, developing technology, and taking that to a very small child is a bit challenging, but we are trying to get hand over it. Improving engagement, the child should get engaged, get involved with education with the help of the technology used. And supporting educators, this is something we need. When we have developed this system, we need the educators to understand that, and when they monitor the child, they see that the growth of the child is very much monitored, and they note that everything is very specifically designed for the child. Moving forward, problem statement. As you can see, this was our problem statement. Our problem statement basically dealt with cognitive needs of a dyslexic student, and their learning styles, their difficulty of how to connect with the real world applications, and not struggle with it. Be very very fluent with everything. If you know, a dyslexic child is not able to concentrate for more than few minutes. If you leave a person, a dyslexic person, in a room, and he doesn't find something interesting, he'll start to hammer, he'll start to get agitated by the whole environment, and the whole thing will cause distress for him or her. So keeping all of this in mind, developing something which is very friendly to the child was very necessary. Methodology, we have gone through the Unity 3D for VR, and we have developed 3D alphabets, objects, phonic audios integrated into our system, so that when the child is interacting with the system, he gets an overhand view of everything in 3D, as well as objects and shapes and everything. So is the testing of this thing, for now we have done, like we asked few teachers and few counseling psychologists regarding this. They have mentioned few points where the child would go beyond the limits, and he and she can react and try to get hold of the technology, but keeping in mind that the educator would be the person monitoring this as well. This is some of our literature review. Something this like AR and VR things are made, but not specifically keeping in mind dyslexic students, and that's what we focused majorly. This is our block diagram. As you can see, a student who would be the user, he she is interacting with the learning platform, and we do the backend stuff, and the provider is also monitoring the child's experience. We cannot just leave the child with the technology. So the whole experience is two-way. The educator also monitors the child's development. Moving forward, some tools and technology that we used recently is Unity 3D for VR, C hash programming for AR and VR both, Blender, Android platform for developing web page, and low cost VR headsets, because we want to keep it as affordable and as reachable for the child as possible. And this is some of the results. So as you can see, there are different shapes and they are of different color. So if we take the VR headset, which we have already done the demonstration of it, if we take the VR headset here and go to the table has few shapes. The child will try to pick it up. So when she picks it up, he can interact with the shapes. So our point being here is you can see the colors used here, they are pastel. So when we were doing our research, we had one point in our mind that the child cannot have dark colors like red, dark blue, because it is very considerate if we see to their color palette. If we see to dyslexic students getting hold of it with their cool color palettes. So we have developed everything with keeping that in mind, and keeping the whole environment very dyslexic student friendly. This is the AR part, which if I'll give this example to you. If you open this app and you scan the QR code, the child will get the hold of the stuff in real world. Now here specifically elephant is mentioned. So the elephant would come out of the table. For just an example, the elephant would stand on the table, and if you ask for the start animation, it will produce the sound of an elephant information. The child will get the information which the teacher can interact and try the child to learn it. And for deeper knowledge, you can use voices and everything. This is a two-way interactive thing. The child can learn and interact with it. Okay. So our conclusion with this project was, when we were testing it, when we were going to the mm, professionals who have seen dyslexic students very specifically, so they have told us about the color schemes, about the interactability of the child with other things. Like even if you keep the child in a normal environment, she has a different tendency of dealing with stuff. So yeah, the whole process when we started the research work to the end point, we had always kept in mind that the child should not get bored, as well as it should not cause trouble to their sensory systems. So concluding, this is augmented reality and virtual reality project, and how we have developed is from a difference from normal child to a dyslexic child is by keeping in mind their color palettes, their learning abilities, their spellings, like how well they can cope up with spelling sentences, and the age limits we have come across, and the traditional, building a different point of view between the traditional system of traditional learning as well as rote learning, by differentiating it with technology, that is AR and VR, implementing things that a child can learn from, interact from, and get a hands-on interactive experience from. So it's, if you if a person, if an educator is present and she provides the comfortable environment, this is a very, very, very peaceful learning method that a child can learn with and get comfortable with the real world without getting the experience or getting the stuff that comes with it. So these are some of the references we had gone through for developing. And moving forward, any questions?
Yes, go to your architectures slide.
Yeah.
Block diagram. So in this, you have mentioned, sir, this left side is just a process, that model.
Yes.
And miss how this and the right side is your actual
How
system
the backend
architecture,
processes. Yes.
the flow of your system.
Yes. So the student, whoever the student is, gets the AR, for now VR headset. If I say it to that VR headset, the VR framework, she will see whatever we have provided for, like a VR learning platform. If you see here, there are interactive learning modules which are developed. Like have mentioned, all the things we kept in mind for giving it to a dyslexic student, multisensory teaching methods and real time feedback, because whatever we are making should have a bit of touch of the child as well. If she or he is comfortable with the whole technology, if the stuff they are seeing is really making them learn something new, is what our focus would be. And the tools and frameworks, as I have mentioned, the technology and tools slide, the Unity and Blender, as well as C hash and languages used, web page
So
used
as
for
you
AR.
mentioned, the interactive learning modules means in that every time it will be in real time. Means
Yeah, because we are not providing any data. We are
offline.
just yeah, we are not providing any data. We are taking the child's data, right? We are giving him or her the platform to learn, and she will provide the stuff. If I just give you an example, we built a system where shapes and cubes or everything is kept in a table, so the child goes, picks it up. Now we are training our data, our system, that the child reacts with circle more. The child doesn't like square that much, so how can we make square interactive? So it is a continuous process.
Okay, so what generally this model will help what age of student?
We specifically kept in mind students from primary, like first standard to seventh standard, because after that the like board or 10th students would get a bit of more syllabus,
Hmm.
and their syllabus would get more handy, right? So our first focus was just, let's just make something for the child to learn education first, then we can enhance it with further developments.
So have you integrated any? So as you said, AR VR tools. So which tools you have used, and have you integrated any AI also in that?
We have used Unity, and for as such for AI we have used for the prompts and whatever we wanted to generate the system, not for the child's perspective, because the child should also get, if we want to implement AI for the child's perspective, it should be according to them, right? So that we haven't done, but we have used AI for our development purpose.
Okay, thank you.
Yeah, thank you so
Over to you,
much.
sir.
Now the next author, Suman, for the paper title Mobile App Performance Testing Tools and Experimental Exploration. Ma'am, do we have?
I'm audible.
Yes, sir, audible. You can start screen sharing.
Good afternoon to all. I'm Suman Morton, a research scholar at Gunandi University, Amritsar. First of all, I would like to talk about the performance testing, which is very essential to ensure that mobile application continue to responsible, stable, and effective in real world usage. And it's a very important topic now and then ever to ensure scalability, responsive for across the different devices and network environment. This is the hierarchy which shows the software testing types. Mainly, the functional and non-functional testing are the two main categories of the software testing. While non-functional testing verify the software performance, and functional testing verify the software actions. And our experiment has been done under device performance, which is used to for application function across devices with various configuration tracking CPU, memory, and battery usage. This is the experimental setup, and our objective of this experiment is to evaluate the performance of the CAM scanner app that used under different load condition. And we have used experimental approach as our methodology. And these are a few tools we have used. First of all, there is a Android Studio Profiler. That is a designated integrated development environment for Android application, a quick and flexible build system based on Gradle. That is a tool for Android Studio for task automation, dependency management, and app packaging. There is a spice that's in the graph indicate the period of high processing load, and green line of thread shows the CPU activities. Next tool is the Aptim tool, which is a tool that help the developer and tester to figure out how to improve the performance, usability, and functionality of the app on iOS and Android devices. And Aptim tool is a supporter testing across a range of devices, operating system, and network condition provide through analytic and reporting the help to track the app performance over time and identify issue and patterns. According to this report, CAM scanner is generally stable but has irregular CPU and frame rates fluctuations. Next tool is a Firebase tool. It's a Google platform for developing mobile and web apps that offer backend services and analytics. It's helped the developer to create, enhance, expand the app rapidly. This graph shows the outcome of the Camp Scanner app on a Firebase testing. The CPU timeline display the CPU utilization as a percentage while the application is running. The resulting graph can optionally shows the maximum memory consumption in kilobytes. The network line is not displaying any activity during testing. Next is the browser tab. It's a testing platform that run on cloud by giving a user instant access to hundreds of real devices and browser. It eliminates the need to maintain the physical device lab. It gives user immediate access to operating system and device combinationally. There is a dependency of network access, and membership fees is its primary drawback. The interface shows the performance profiling metrics. The application does not use a lot of resources and operates efficiently in terms of CPU and memory usage. Particularly when utilizing the camera feature, dropping frames and FPS indicate that there is maybe lag, there may be UI lag. This is to be expected for the cam scanner app that processes image in real time, but optimization could enhance the user experience. Next is Apache JMeter. Apache JMeter software foundation created by JMeter to assist developer and tester in simulating the actual user load on application. That's an open source performance testing tool. Although JMeter is very flexible and open source, configuring and interpreting data require greater expertise in technology. This is a comparative table so that shows we work on of these performance testing parameters. Next one is a comparative for the tools, ease of use, integration capability, and applicability of the different apps. The app scalability, this is the conclusion. The app scalability, responsiveness, and stability are granted through the performance testing. The outcomes and effectiveness of mobile application performance testing tool are the main concern of this study. And there is a both commercial and open source tools were used. And their conclusion is Android Studio best for device leveling, Firebase for backend monitoring, and browser stack for the real devices testing, acting for focus only and user performance, and JMeter server side validation. And tool selection was specific for the performance metrics and testing goals. And the future work is exploring AI powered tools, techniques for mobile app performance testing to enhance the automation predictive analysis capability. These are the references. Thank you. Can you go to your objective slide? Yes, ma'am. This one. It is experimental setup. Have you find out the objectives for your topic? Ma'am, I have concluded all tools on this. Okay, just wait. Okay, from this, what you have been what you have been gotten, you have done the comparison of the tools, right? So, which is the best as per your research? Ma'am, according to open source, JMeter is the best, but there is a complexity of the JMeter to how to use. According to their requirement, developer and tester can use their tools according to their prospectus. Because JMeter is open source, but best tool is a Firebase. But this is there is a cost problem. It's because subscription is very high. So according to requirement, people can change their tools selectivity. So it is not like out of these tools it is best or what like way. It can be applied as per the requirements. Yes, ma'am. Right? Yes, ma'am. Okay. Yes, ma'am. Fine. Thank you. Thank you, ma'am.
I would like the next author, Muskan, with the paper title Modern Data Structures for Machine Learning, a Comprehensive Survey in Future Directions.
Good afternoon, all. Am I audible?
Yes, you're audible.
Okay, I'm sharing the screen.
Yes.
Is the screen visible?
Yes,
Yes,
ma'am,
it's visible.
Okay, so I am Muskan, and my topic is modern data structures for machine learning. It is a comprehension survey and future directions. So, if I talk about its introduction, so machine learning are now widely used in areas such as healthcare, finance, cybersecurity, and smart cities. While most research focuses on improving algorithms, performance, and scalability of ML systems, also strongly depends on how data is stored, accessed, and processed. Traditional data structures like arrays, trees, hash tables were designed for static and sequential workloads, and they are struggle to handle large scale, high dimensional, and distributed nature of modern machine learning data. So modern machine learning requires scalable, adaptive, and hardware aware data representations. So as a result, there has been a shift toward modern data structures such as tensor based, graph based, and distributed representations, and they are better suited for today's machine learning pipelines. This survey examines these developments and highlights their role in improving efficiency and scalability. So this is the motivation and the problem statement. So the motivation is the rapid growth of machine learning applications has led to significant increase in data volume, dimensionality, and system complexity. Modern machine learning systems are often distributed, dynamic, and hardware intensive, which places new demands on how data is organized and processed. However, most classical data structures were not designed to support such workloads. Although recent research has introduced tensor-based, graph-based, and distributive data models, there is still no unified understanding of how these data structure design influence learning performance as well as the system efficiency. So existing studies focus on algorithms or frameworks, while the relationship between the data structure design and machine learning performance remains underexplored. So here is the problem statement. Despite the growing importance of efficiency in modern machine learning, there is no unified perspective that systematically connects data structure design with machine learning performance and efficiency. So these are some objectives. Like first is to systematically review recent data structures that have been designed or adapted specifically for modern machine learning systems, and to analyze how different data structure designs influence computational efficiency, memory usage, scalability, as well as learning performance. To organize existing research into a clear taxonomy covering tensor-based, graph-based, search-optimized, and distributed data structures. And to identify key limitations in current approaches and highlight open challenges and future directions for machine learning-oriented data structures. So this is the survey methodology. So this survey is based on peer-reviewed research published between 2020 to 25 and some many more years, and it focuses on development in machine learning oriented data structures. And relevant studies were collected from IEEE Explore, ACM Digital Library, and Scopus. And paper were selected based on their relevance to tensor representations, graph data structures, indexing methods, and distributed or federated learning systems. The selected literature was analyzed and compared with respect to computational efficiency, memory usage, scalability, and impact on machine learning performance. So here we discuss the role of data structure in the machine learning pipeline. So from the data ingestion to processing, data structures are widely used in machine learning. And during data ingestion and pre-processing, structure storage formats such as columnar stores and sparse tensors reduces memory usage and input-output overhead. In model training, tensor layouts and gradient aggregation structures directly influence computational speed and hardware utilization on GPUs and TPUs. And in graph-based learning, relies on specialized adjacency and partitioning structures to support efficient neighborhood sampling and scalable GNN training. And for retrieval and inference, indexing and similarity search data structures enable fast access to high dimensional embeddings. And in the last, distributed and federated learning, communication aware data structure manage parameter synchronization while minimizing latency and bandwidth usage. So this is the figure that mentions that to summarize how the data structure interact across the machine learning pipelines, and this figure presents a conceptual architecture of machine learning aware data structure ecosystem. So this figure shows that how the data structure used throughout the entire machine learning pipeline, and starting from the data collection and representation, the data structure supports efficient training, learning, and inference. It also shows that the learning process can influence how the data is organized. And the workflow starts with the data ingestion and representation using suitable data structures. And this data is then used for model training and learning. Based on the learning outcomes, the data organization is optimized to feedback loops. Finally, optimized structures support efficient inference and deployment. So here are some taxonomy of modern data structures, like storage-oriented structures, search-optimized structure, graph-centering structures, and distributed and federated structures, adaptive and emerging structures. These are the hierarchical categorization of the data. Like storage-oriented structures focus on the efficient organization of the sparse tensors to improve the memory locality. If I talk about the search optimized, so they are designed for the fast similarity and nearest neighbor queries in high dimensional embedding spaces. And in graph centric structures, it support learning over relational and network data through spatial adjacency formats and partitioning strategies. And in distributed and federated structures, it manage parameter storage, synchronization, and communication across multiple nodes while preserving scalability and privacy. Adaptive and emerging structures, it incorporates learning aware, energy efficient, or quantum inspired designs that dynamically adjust to workload and hardware conditions. So, this is the hierarchical taxonomy that I discussed in the previous slide. So, and the next, we use like tensor and storage oriented data structures for modern machine learning applications. So, modern deep learning frameworks rely on dense and sparse tensor layouts to store model parameters and intermediate activations efficiently. And cache aware and block based tensor formats significantly improve computational speed and hardware utilization during large scale training. And overall, tensor-based data structure improve training speed, memory efficiency, and hardware utilization, making them essential for large-scale deep learning systems. So next is graph-centric search-optimized data structures. And so graph-centric data structure are used when data has relationships, such as connections between users and nodes. They store data in form of nodes and edges, which helps machine learning models to learn from the relationships. These structures are widely used in graph neural network. And some search optimized data structures are designed to quickly find similar data points in large data sets, and they are especially used for tasks like recommendation systems and information retrieval. And together, these data structures help machine learning system handle complex relationship and make them fast, accurate predictions at scale. Next is distributed and federated data structure for machine learning. So distributed data structures are used when machine learning data and computation are spread across multiple machines. They help store and process large data sets in parallel, and which improves scalability and reduces training time. And federated data structures are designed for settings where data cannot be shared directly, such as in healthcare or mobile applications. In this case, data remains on local devices, only model updates are exchanged. And in these data structures reduce communication overhead, improve privacy, and uh, and enable large scale learning across decentralized.
Hello? Ma'am, I guess there are some technical issues with that side. So, do we start with the next presentation or do we wait?
Yes.
Sure. The next author, Abhirup Padate, for the paper title Wind Speed Forecasting Using Hybrid Machine Learning Approach.
Yes, sir. Thank you.
Yes, you may start.
Yeah. Mm. I hope my screen is visible.
Mm, yes, it is now.
Yeah. So, good afternoon, everyone. Today I will be presenting our work titled Wind Speed Forecasting Using Hybrid Machine Learning Approach. This work is carried out at the Department of Electronics and Telecommunication Engineering at KJ School of Engineering, Somaiya University. The primary objective of this research is to improve short-term wind speed prediction accuracy using hybrid machine learning and signal decomposition techniques. So, sorry. One minute. Mm. Can I share my screen? I'm not able to change the slide.
Yeah, sure.
I hope it's visible now.
Not right now. Yeah, it's visible. You can start.
So, wind energy plays a crucial role in modern renewable power systems. However, efficient integration of wind energy into power grids strongly depends on the accurate wind speed forecasting. The major challenge is that wind behavior is highly irregular, non-linear, and non-stationary, meaning it changes unpredictably over time. Traditionally, statistical models like ARIMA struggle to capture such complex patterns, especially the long-term dependencies. On the other hand, single deep learning models often fail to generalize well under varying atmospheric conditions. Therefore, in this work, we try to focus or propose hybrid deep learning frameworks that combine signal decomposition techniques like DWT and VMD with neural architectures such as CNN, LSTM, and BiLSTM. So, after going through several studies, recent studies showed that hybrid approaches outperform standalone models. For example, VMD-based hybrids have shown significant error reduction. Perry and Tripathi proposed VMD SciNet model that reduced prediction error by nearly 80%. And similarly, wavelet-based models have proven effective. Uh, w- Bargest and co-authors combined DWT with BiLSTM and BiGRU, achieving substantial reductions in mean absolute error and RMSE. However, existing studies focus on only one hybrid architecture. The key research gap addressed in our work is the systematic comparison of multiple hybrid models, particularly VMD-based versus DWT-based frameworks, on the common benchmark dataset. The dataset we used was Solid Pombo 60-minute dataset collected from SysLab facility in Denmark. The dataset spans from June 2018 to to September 2019 and contains 10,989 hourly samples. It includes wind speed along with meteorological parameters such as temperature and humidity. Prior to training, missing values were interpolated and obvious outliers were corrected to ensure data quality. This dataset provides sufficient temporal depth and variability for evaluating short-term forecasting models. As a baseline, we first evaluated the RNN GRU LSTM model on raw data without any pre-processing. In this architecture, RNN was used for basic temporal memory, GRU was used for efficient gating mechanisms, and LSTM was used for long-term dependency learning. While this model captures temporal patterns reasonably well, its performance is limited due to noise, non-stationary in raw wind data. This baseline serves as the reference to evaluate the effectiveness of pre-processing techniques. I would also like you to note that this same model was used in other papers that we surveyed. Moving on to pre-processing, to improve prediction accuracy, we applied variational mode decomposition, or VMD in short, as a pre-processing step. VMD decomposes the wind speed signal into seven intrinsic mode features, or IMFs in short. Each represents different frequency components. These IMFs capture both high frequency fluctuations and low frequency trends. The parameters were selected empirically to balance convergence and frequency resolution. This decomposition allows downstream models to learn from cleaner and more informative signals. We then developed a hybrid model combining VMD with ARIMA and deep learning. On the left-hand side, we can see in the VMD ARIMA LSTM framework, ARIMA models the linear component of the signal, while LSTM learns the non-linear residual patterns. To further enhance feature extraction, we introduced CNN layers on the VMD ARIMA CNN LSTM model. Here, CNN captures the localized temporal patterns from IMFs, while LSTM models the long-term dependencies like always. These hybrid significantly outperform the baseline model. We also propose a DWT Okay, so, sorry. We also, in addition to VMD, we also explored discrete wavelet transformation or DWT for signal decomposition. DWT is particularly effective for non-stationary signals and sudden variations in wind speeds. We proposed multiple DWT based hybrids, including the DWT GRU by LSTM and DWT CNN by LSTM. Among these, the DWT CNN by LSTM model integrates DWT for multi-scale decomposition, CNN for spatial feature extraction, and by LSTM for learning dependencies in both forward and backward time directions. This model achieves the best overall performance. We also propose a DWT Profit by LSTM hybrid model. Profit is a statistical forecasting tool which effectively captures trends and seasonalities, while BiLSTM again learns short-term dynamics from residual components. This hybrid approach combines classical time series modeling with deep learning and shows robust performance across varying timescales. Uh, then moving on to the results, we evaluated all models using mean absolute error, RMSE, and R squared matrix. Uh, the baseline RN and GRU LSTM showed limited accuracy due to raw data noise. VMD based hybrids improved performance by learning linear and nonlinear components separately. Uh, However, the DWT based models consistently outperformed VMD based models. The DWT CNN by LSTM model achieved the lowest RMSE of 0.30 and MAE of 0.41, confirming its superior ability to capture complex temporal patterns. We can also see the performance visualization of DWT CNN by LSTM model, which was the best. Then moving on to the conclusion. To conclude, this study demonstrates that signal decomposition significantly enhances wind speed forecasting accuracy. Among all evaluated models, DWT, CNN, BiLSTM achieved the best performance, outperforming both VMD-based and baseline models. The results confirm that combining CNN for feature extraction and BiLSTM for sequence learning, supported by wavelet-based pre-processing, provides a robust and reliable forecasting framework. This approach can greatly benefit wind energy integration and power grid management. Moving on to the future scope, future work can extend this framework towards real-time forecasting using online and reinforcement learning. Lightweight versions of these hybrid models can be developed for edge deployment on wind turbines itself. And additionally, integrating spatial data sources such as satellite or LiDAR measurements and exploring maybe transfer learning can further improve robustness across different wind farm environments. Thank you. Any questions?
Is it feasible to implement on 10,000 data set as you mentioned? So is it working on that data set or limited data set?
We only used one data set with 10,000 records. Each record
Okay, yeah,
was,
so that each records has been tested, right?
yeah, it has. It has. Yeah.
Okay, so where do you store this large amount of data? Is it on a Google cloud or where like the backend is connected on what platform?
We did not use the complete data set because we just used the time series. We just used the wind speed, and this was all done on Google Cloud itself, like using Colab and stuff.
Okay, and have you have compared all the models, right? With the
Yes,
previous model as well. So
yes,
your model that your proposed model is giving you the best result
yeah,
on this data set.
yes, ma'am.
So you have mentioned, okay, fine. Yeah, thank you.
Thank you, ma'am.
Yes, ma'am. I sincerely thank all the authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of this conference. We'll be very happy to host you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months, so kindly cooperate with the same. I also thank our session chair for their valuable insights. And one second, ma'am. This is the token of appreciation to Professor Swarna Patil for their knowledge sharing. Could you please end it with some words?
Yes, 1 minute. Thank you. So thank you. So I, Dr. Suvarna Patil from DY Patil University. So thank you all of you for thank you organizing team for giving me this opportunity. So hope in future also we will have some such collaborations, and I will be happy to collaborate with you. Thank you.
Thank you, ma'am. I request everyone to please switch on their videos as I have to click a virtual photo.
Actually, there is some problem from my side to my
Yeah, no issues, ma'am. Thank you very much.